Hello students, welcome to the Quick Solutions All India AIATS Test Series JEE Main 2020 Test 7 Physics. Let's go to question number 1. Question 1 says the linear momentum of a body is determined by measuring its mass and velocity. If the relative error in measuring the mass and velocity are 1% and 2% respectively, the maximum error in determining the momentum is. Well, we can see that the question is from the topic errors and specifically propagation of errors. So let's write the expression for momentum. We know that momentum is simply mass into velocity. So momentum P is mass into velocity, and there are errors in measurement of mass and velocity. So the relative error in momentum delta P by P is sum of relative error in mass and velocity. That means delta M by M plus delta V by V. Now we already have the values of delta M by M, the errors in mass and velocity, which are 1% plus 2%, and that means the relative error in momentum that can be there, the maximum value is 3%, which means option 3 is correct for question 1. Let's go to the next question now. Question 2 says figure shows location of particle A and B at t equal to 0. Both the particles A and B are moving toward O with constant speed of 18 meter per second and 6 meter per second respectively. At the time of minimum separation, location of A and B respectively is left of O and below O, left of O and above O, right of O and below O, right of O and above O. And this diagram is given to us. Obviously the question is based on the concepts of relative velocity. So what we do is we draw velocity of B with respect to A in this diagram, and that vector passing through the position of B at time t equal to 0. So that means we have something like this. This is position of A at t equal to 0. This is position of B at t equal to 0. This is 5 meters and this is 12 meters. This is 5 meter and this is 12 meter. And if I connect the line B, A, this angle alpha will be tan inverse of 12 by 5. So this is tan inverse of 12 divided by 5. And the velocity of B vector is something like this, VB vector. Its magnitude is given as 6 meter per second. It's of course directed towards O. Minus VA vector is something like this, and its magnitude is 18 meter per second. And the velocity of B with respect to A will be the resultant of these two vectors, so it will be something like this. It is something like this. This is velocity of B with respect to A, and if I call this angle as beta, the angle beta is tan inverse of 18 by 6. That means tan inverse of 3. So we can judge that beta is clearly greater than alpha. So this velocity vector of B with respect to A is directed at a greater angle than the other one with respect to line BO. And if I extend this line, this is the position of B with respect to A when they are at minimum separation. I can call it RBA vector. Now this is a very key point of solving this problem. the key point is, given the options, we don't actually have to find their exact locations when they are at minimum separation. Basically, we have to judge how they are positioned with respect to point O, the particles A and B. And answer is given by this vector. We can see that clearly this vector is tilted towards right with a vertical line through point A. Now that will happen only when A is to the left of O and B is above O. So something like this. Remember, with respect to ground, B is moving along this line only. So B will be somewhere on this line. And this condition, the fact that position of B with respect to A is tilted towards right with respect to line OB, is satisfied as per this situation only. So our answer to the question will be option 2, which says left of O and above O. That means position of A at the time of minimum separation is to the left of O, and position of B at that time is above O. So option 2 is correct. Let's now go on to the next question. Question 3 says, in the figure shown, block M1 is placed over M2, which in turn is placed over rough horizontal surface having coefficient of friction 0.1. Coefficient of friction between M1 and M2 is 0.2. If M2 equals 2M1 equals 10 kg, then maximum value of force F, which can be applied on M2 so that both the blocks move together, is, and it's given G is 10 meter per second square. Well, the question is from the topic laws of motion, and it includes friction too. So what we do is we look at free body diagram of M1. With respect to M2, M1 has a tendency to slip towards left. So friction on M1 is towards right. So on M1 you have its weight M1G, and M1 is 5 kg, so this is say 5G or 50 Newton. There is normal reaction N1 applied by M2, and there is frictional force F1. Let's say its acceleration is A1 towards right. We can see that the maximum acceleration M1 can have is, let's say, A1 max or A1M, and that will be equal to the maximum frictional force, which is 0.2 into 5G divided by its mass, which is 5 kg. So the maximum value of acceleration of block M1, as we just found by simplifying and calculating further, this value is 2 meter per second square. Now in the next step, to find the maximum value of force F for which both blocks move together, we can consider both the blocks together as one system which has acceleration 2 meter per second square, and the force which will be opposing their motion is the friction by the horizontal surface. And when the blocks are moving, the friction of the value of this friction, let's call it F2, is mu at this point, which is 0.1 multiplied by normal reaction, and which is 15G or 150 Newton. So the value of friction at this point is 15 Newton when the blocks are moving. So our equation now is F minus 15 Newton equals the total mass, which is 15 kg, into 2 meter per second square, and this gives us the value of F max, which we have to find as 45 Newton. Well, the option 3 matches with the answer we've got. So option 3 is correct for this question. Let's go to the next question now. Question 4 says, a particle moving in a circular path of radius r adjusts its speed in such a way that tangential acceleration and centripetal acceleration of particle are always equal. Distance traveled by the particle before its speed gets doubled is proportional to r square, is dependent on its initial speed, is proportional to r, is independent of r. Okay, obviously the question is from the topic kinematics or motion in a plane, and we have, well, the condition given is that the tangential acceleration and centripetal acceleration always have same magnitude, which gives us the condition that v square by r, the centripetal acceleration is v square by r, is equal to dv by dt, the rate of change of speed. Okay, the magnitude of dv by dt equals v square by r, and since we have to bring in distance also, so we can write dv by dt in the form of dv by, let's say, dl into dl by dt, where L represents the distance travelled and dl by dt is again v, so we have it as v dv by dl. We could have also got this result by simply applying the chain rule, and so this is the expression that we have, and if we just do the cross multiplication, we get dl by r equals dv by v. Now we can use the condition that's given in the question, that the speed of the particle is doubled. So if I integrate, let's say speed goes from v0 to 2v0, whereas distance travelled is L. So this gives us L by R equals ln 2, and that means the distance travelled L is equal to R ln 2. So it's clear that the distance travelled is proportional to radius r, which means option 3 is correct. Let's go to the next question now. Question 5 says, in a head-on collision, a particle with an initial speed v0 strikes another identical stationary particle. If the loss in kinetic energy is 75% of the maximum loss which can occur, then final speed of striking particle is. Well, obviously the question is based on head-on collision between two particles of equal mass, one of which is stationary. Suppose the situation is depicted like this. We have the striking particle. Let's assume it's going with speed v0 and it strikes another particle which is at rest initially. The collision is head-on. After collision, we can call this particle 1, we can name this particle 2. After the collision, well, the first particle has velocity v1 and the second particle has velocity v2. We can see that v2 we can expect to be greater than v1 for sure. Now, the loss in kinetic energy is 75% of the maximum loss which can occur. So let's look at the condition when maximum loss in kinetic energy occurs, and that is the case when the two particles stick to each other. The collision is perfectly inelastic. So let's look at the loss of kinetic energy if the collision was perfectly inelastic. So in that case, mv0, conserving linear momentum, we will get it as 2m, because both particles will have same velocity, into, let's call it v, the final speed, and this gives us v is equal to v0 by 2. So maximum loss in kinetic energy, so maximum loss in kinetic energy possible is half mv0 square, the original kinetic energy of the particle, minus the least possible kinetic energy of the two particles together is half 2m into v0 by 2 the whole square, and on simplifying we can see that this value is 1 by 4 mv0 square. Okay. Now it's given that the loss in kinetic energy in this particular collision is 75% of this, that means 3 by 4 of this. So we get the equation half mv0 square is the original kinetic energy again, minus half m V1 square minus half m V2 square, but by conserving momentum we can see that mV0 equals mV1 plus mV2, or V2 can be written as V0 minus V1. So that means we can write here V0 minus V1 square. So this is the loss in kinetic energy, and this is 3 by 4 times of maximum possible loss, which is 3 by 4 times 1 by 4 mV0 square. Let's simplify it further. Well, simplifying this, we will get a quadratic equation in V1, right? We can cancel all m's. M's are there on both sides with each term, so the terms can, the mass m will be cancelling on both sides, and we will be left with a quadratic equation in V1, and solving which and applying the condition that V1 is less than V2, we can see that the value of V1 is coming out to be V0 by 4, which matches with option 1. So option 1 is correct for question 5. Let's go to the next question now.